our last section of chapter 4 today. So the map of where we're headed. And, we've got 4 sections out of chapter 4. And so rates, ratios, percentages, proportions in chapter 4. And then we've got 2 sections in chapter 6, which are geometry. So we'll do geometry stuff next. And then we've got 2 sections out of chapter 7, and which is a little bit of probability. It's not too in-depth, but a little bit of probability there. And then we'll be ready for test 2. So test 2 will be these 4 sections, 2 geometry sections, and 2 probability sections. The late section. Okay, anybody have any questions or anything we need to do before we start going through this section? All right. This is not a long section and it's not a hard section. Okay. A lot of this we're kind of just thinking about practical uses of percentages. And so calculations are not bad. There's only a couple. And, most of it we're just thinking about some practical ideas. Okay. All right. Oh, and I need to remember, since this is my last opportunity to remember, Friday, we're gonna let it be another Hawks Day. I think that went well last time. Okay, so Friday, we'll just be working on Hawks together if you want to. Okay. If you're all caught up and you don't have to worry about it, you can do what you want to on Friday. Okay. If you need any Hawks help, we'll be working on it together. Trying to help keep everybody caught up. Okay. So maybe I'll remember to post an announcement on Canvas for that, but at least all of you that are here today will know. Okay. Okay, let's get into it then. So really we have 3 things we're going to do. This one just lists 2 here under our objectives. Okay, we're going to talk about kind of some shortcuts to estimate some percentages. And then we will talk about percentage increase or percentage decrease. And then the last little part of the section, we're just looking at things you need to pay attention to when people are using percentages and you're seeing those. There are some things people do with percentages that don't make sense. They're really commonly done, so you want to be able to look out for those. So that'll be our last thing there. So the first topic in this section, we're talking about tipping. Okay. Not every country works on a tip system. Okay. And apparently, the United States is one of the countries that has the highest tip rate. Okay. We're expected to tip places. So generally, let's say 15 to 20%, and you can vary it on service around like how good do you think your service was. Okay, but let's just, I know what, if you're not math savvy, okay, what you do if you want to figure out what you need to tip, what do you do? Like if you go out to eat with your friends and you don't know how much to tip, what do you do? I'm just asking like you personally, what do you do? Double tax, okay, so that's a good strategy. You can double the tax. Around here, that works pretty well. You can also, there's apps. Okay, there are apps you can use too. So yeah, doubling tax is good idea. But maybe we need to figure out what we're going to tip before we get a receipt or something. Maybe we know what our total is going to be. We don't have not the total, but we know what our bill is going to be, but we don't have the tax sheet or something. Okay, so another thing we can think about is there's a trick that makes it easy to find 10% of a number. Anybody think about that? If we want to find 10% of a number, all we have to do is move the decimal place. If you've seen that, thought about that before, I get 10%. Okay. And that idea is really helpful on lots of things, not just tipping. But it can be helpful tipping here. Okay. So that's one thing that makes our number system, our base 10 number system that we use, easy. Okay, is that if we want to change something by a factor of 10, we just move the decimal place. Okay. So a little bit of side trivia here. So we call our number system that we use from day to day, numbers we count with, things like that, the base 10 number system. We have 10 digits we use, 0 through 9. Anybody know why we use base 10? You might not have ever even taken a second to thought about any other options, but I got any idea? It's not like a really scientific reason or anything. So we use base 10 for some reason. What's special about 10? What do you do when you're learning to count? Yeah, what do we have 10 of, most people? Yeah. We have 10 digits. 10 digits. Okay. And that's really the only reason why we use base 10. Okay. We could use all kinds of weird number systems, okay? But base 10 seems normal to us. Okay, it's a little trivia there. Okay. All right, so this idea of taking 10% of a number. So then we can use that to estimate a tip. So let's look at a few. So 10% would be easy. And usually you want to tip a little more than that. Okay, but, 10% tip would be easy. Like if we had a $25 bill, you move the decimal place, get $2.50. That's 10%. So even on a bigger number, that works. You move the decimal place once and get 10%. Usually trying to estimate a different percentage, starting with 10, is a good starting place. Okay? Because then if we wanted to leave like a 20% tip, and we know 10% is $2.50, and you just double that. Okay? Same idea as doubling tax. Right? Okay. What about if we wanted to leave a 15% tip? That one's a little bit trickier, but we can get close, right? We don't have to get exactly 15%. So like if we wanted to know 15% of $25, we wanted to tip 15% there. Well, if we start with 10%, 10% is $2.50. We need 5 more %. So we can think about half of this. And instead of doubling something, we can think about half of it. So we'd add another $1.25. It'd be $3.75. And again, make the numbers easy. You can. It's not a big deal if you mean to tip 15% and you accidentally tip 14.9%. That's not a, or you accidentally tip 15.1%. And that's really not a big deal. So just make the numbers easy. Okay, so that's one little mental trick we can do. Let's actually calculate one. So we're going to do the math behind this one. And it's not hard. Well, let's do it both ways. Let's estimate, and then let's actually punch it in the calculator. Okay. So it says our lunch bill is $9.84. Okay. Let's approximate how much would a 15% tip be, and then how much would a 20% tip be. So try to get close in your head first if you can. You don't have to be exact. Okay. So, did you try? So what I would do, I would say $9.84 is really close to $10. And so that makes that easy. 10% of $10 would be $1. So 15% tip should be about $1.50. And the 20% tip should be about $2. Okay. And then we can punch it in the calculator if we want to be exact. So how do we do that? We want to know how much to tip. 15% Sorry, my screen's acting up up there. 15% as a decimal. Now we move our decimal place 2 places to the left, so 15% as a decimal is 0.15. So we could do 0.15 times $9.84. That'll tell us our 15% tip. Okay. Let's see how far off we were with the mental math. So 0.15 times 9.84. If you round to the nearest cent, that's $1.48. Just doing it the mental way, we would have tipped 2 extra cents. Okay, big deal. And then for 20%, what's it going to be as a decimal? Yeah, 0.2. Okay, so 0.2 times 9.84. See what we get there. If we round to 2 decimal places, that's $1.97. So we can get really close without having to break out a calculator on that one. And some numbers are harder to deal with in your head than others, right? Like if our bill had been $17 instead of $10, that's trickier. All right, just something to think about there. If you didn't know the decimal trick, then most of you probably did, but if you didn't know the decimal trick, that's really nice to know. Other thing we're going to talk about briefly here, same idea, but we're dealing with sales tax. So we can kind of use the same trick to get a mental estimate as the tipping. So we don't really have to talk about that. But there's something else that, I don't know, there's like a gap in middle school, high school education for some reason. Seems like everybody teaches doing a sales tax problem the same way. Okay? And there's more than one way you can work them. So let me go back. Let's don't pay attention to that yet. So think about this. If we have a total of items, right? And our item total comes out to $22. Okay. And I told you it was 8% tax. Okay. And we want to figure out how much total we're going to end up having to pay. Pretty much everybody works this problem the same way. Okay. So what would you do? We would typically figure out what 8% of 22 is. Right? So 0.08 times 22. That'll give us the tax. And then to get the total, what's the last step? We got the amount of the items, we got the tax, and then to figure out our total, we just add them together. Anybody work it different? Like if I made you work that problem, you got a different idea? That's pretty much the way we're all taught to do it. Okay? But that may not be the easiest way. It may not be the easiest way. So let's think about this other idea. Okay. And it might take you a second to wrap your head around what we're doing here, but after you get it, it makes sense. Okay? After it clicks. So we've got to pay 100% of the price of whatever our items are. Right? We've got to pay that whole price. Plus, we've got to pay some percentage sales tax. So what we can do is we can take the 100% for the items we have to pay for, plus whatever percentage it is that we're paying in sales tax, We add the two percentages together, and then we take our total percentage and multiply it by the cost of the items. And we can figure out our total price that way. Let's do one. Let's put some numbers on one here. Well, here's one that we can look at. Okay. So here we got items with a total price of $25, 4.2% sales tax. Okay. So the normal way people work that problem is they take $25 times 0.042 to figure out how much tax we have to pay. So then we would take the cost of the items plus the tax and get our total, tax included, $26.05. But the other way we can do it is we take our 100% that we're going to pay on the item plus the 4.2% tax, get 104.2%, change that to a decimal, 1.042, and multiply by the cost of our items, and we get the same thing. That one this is usually easy to do in your head, right? Adding the two percentages together, because it's usually 100% plus something. Okay? And then you just have to multiply. You don't have to add. Not to add. So let's look at one. Do one on our own. Let's look at this one. It says find the total price of any 32-inch TV that sells for $219.99 if purchased in Georgia, where the sales tax is 4%. And we're going to also do it for Kentucky if the sales tax is 6%. Okay. So our item cost is $219.99. Okay. And let's do Georgia first, where we got 4% tax. Okay, sorry. So $219.99 our item. Get back to red here. Okay. So kind of the traditional way I work in this problem, Georgia was 4% sales tax, it said. So if we do 4%, then we would do 0.04, right, change 4% to a decimal, times $219.99, figure out how much tax we have to pay. There, if we round to the nearest cent, that rounds a little weird, but that's $8.80 tax. And then we would have to take the price of the item plus the tax to get our total. So that would be $228.79. Okay, that's kind of the traditional way. Doing it that way makes sense? Figuring out how much tax we have to pay, and then we just add that to the item cost. Okay. All right, let's do the Kentucky one. What was it, 6%? Let's do it the other way. So 6% tax plus 100% of the item cost, we would end up with 106% that we're having to pay. So we would do 1.06 times our item cost. And when we get that answer, we're done. So 1.06 times 219.99. Now I get 233.19 when we round. To me, that way is a little, I like it better. Okay. I'm going to do two. We're still doing two steps really, but the first step's easy. It's 100% plus whatever our sales tax is. I don't have to use a calculator for two steps. You can do them either way. It doesn't matter to me which way you do them. Questions on either one of those? Sure are quiet. I said I was going to bring candy or something, didn't I? I have to remember that. Get like a pinata and hang it up here or something, and every time you ask a question, you get to come take a shot at the pinata. I don't know, come up with something. Get some motivation going. Okay. Let's see. All right, one other little application here, and it's really the same idea as sales tax. We're just kind of going the other direction. That's if we have a sale price. All right, it's the same method. Just at the end, we're subtracting instead of adding. If you're doing it the traditional way. So one thing the textbook mentions here is usually if you got a percent sale, it's not some weird number. Like normally you don't see an item advertised as 73.5% off. Right? They normally say it's 70% off or 75% off. Okay, so that makes kind of that idea we used with the tipping of just moving the decimal place pretty valid, or if you're trying to estimate a sale price. Okay. Usually the numbers are pretty easy to work with if you do just a little bit of rounding. The less thing about doing it with a calculator here if we're actually trying to get the exact number. Okay. So here we've got 40% off our discount. We got a sofa, the original price was $496. Okay. They're using the shortcut idea here, but we can calculate it exactly right. What we do, if we're taking 40% off, we could do 0.4 times the price. That'll give us our discount, and then just instead of adding like we do with sales tax, we subtract. So I won't bore you with doing that whole thing. Let's see, we do have one we'll do. Let's do this one, okay? So let's estimate it, and then we'll do it with a calculator. Okay? This one says find the sale price of a new sweater that is 40% off the original price of $88. Okay. So if I'm just trying to quickly estimate what that's going to make the price, I would probably call that $88 $90. So then 10% of 90 would be 9. Move the decimal place once. I need 40%, so I'd have to do 4 times that. It'd be $36 off. And we could subtract. What would that be? $52? Let's see how close we get if we do it with the calculator. So figure out our discount. We do 0.4, 40% as a decimal, times $88. When we get there, that would be $35.20. And since this is a discount, we would subtract that from our original price. So $88 minus $35.20. 5280. Oh. Got pretty close with our estimate there. Or, that's good we do it. This one I like even better than doing the sales tax this way. So let's think about our percentages to start with. If our sale price is 40% off, then that means what percentage are we going to pay? We start with 100% minus 40%, so what percentage are we left with? 60. So if we want to figure out our sell price, we can do it really quickly. Okay? It's just 0.6 times 88. Get there. Yeah, same thing. To me, that's much smoother than having to do the 2 steps that we traditionally do. Because if you do it the traditional way, it's just using the calculator takes quite a bit longer than even just checking it in your head, right? But if you do it this way, you're kind of splitting, doing part in our head, figuring out the 60%, and then it just makes it go quicker. I like it better. Questions on that one? Okay, so let's look at something maybe a little less day-to-day here, a little less mundane. Our second objective in this section is to talk about absolute change. And then really our objective is to talk about percentage change. But we have to talk about absolute change first. And the idea here, all we're doing is we're taking an original amount that something was and a new amount and subtracting. And all we're doing with absolute change is we're taking the absolute value. And so we don't care if our answer is negative, we make it positive. If our answer is positive, we leave it positive. Okay. That's kind of nice. It makes it where we don't care which number we put first in the calculator. Okay. Just know that whatever number you get, we make it positive. Okay. That's absolute change. And the reason we want to know that is because we want to be able to talk about percentage change. Percentage change, we take our absolute change and divide it by the original amount, the amount we started with. So that's important. Okay. So the fact that we're dividing by the original amount, not the amount after the change. Okay. That's important. And then the formula says we multiply by 100%. Okay, that's all we're doing is we're changing the decimal we get to a percentage. Okay. To me, that's always a little confusing when they have times 100% in the formula. Let's try a couple of these, okay, so you can see what we're talking about. Okay, look at one here. One says we got an on-campus organization. They're trying to increase their monthly attendance. Part A says if after a big recruiting push, the meeting attendance increased from 25 to 38 people, what was the percentage change in attendance? Okay. So first we just subtract the 2 numbers. And I'm even going to be lazy and just do 25 minus 38, but we've got to take the absolute value and get the absolute change. So 25 minus 38 gives me negative 13, but we want positive, so 13, my absolute change. So then to get percentage change, we take that 13, and what are we going to divide it by? 25 or 38? We got to divide it by the original amount, right? So the amount before the change happened. So here, we're going to divide it by 25. So if we do 13 divided by 25, it's 0.52. And then we just change it to a percentage. That's what the times 100% meant. So this is 52%. That's saying the attendance increased by 52%. And how do I know it increased? Because the old number was 25 and it went up 38. Okay? Up 38. What about B? B says during the third meeting only 31 people attended. What was the percentage change from the second meeting to the third meeting? Okay. All right, so at the second meeting we had 38 people. The third meeting we had 31. Okay, so let me get some more room here. We had 38, now went down to 31. So what's our absolute change here? It's just 7, and just subtract. But then to get percentage change, we're going to take our absolute change and divide that by the original number, which here is 38. And then change that to a percentage. So 7 divided by 38. That's 0.1842, and it goes on and on and on. So if we change that to a percentage, that's about 18.4%. So is that 18.4% increase or decrease? Decrease, right? We just have to look back at the numbers because it went from 38 to 31, so we're going down. Okay. So 18.4% decrease. Okay. One more part here. Oops, sorry. Great, give me 1 second. Sometimes when I accidentally zoom, it freezes. Detach this thing and reattach it and it'll unfreeze. C says for advertising purposes, the organization decides to promote the overall increase in attendance for the 2-month span since it has increased from the original number of attendees. So here we want to do the percentage change from meeting 1 to meeting 3. So let's go back and look at our numbers. Meeting 1, we started out with 25 people. Meeting 3, we had 31. So we're going from 25 to 31. That's an absolute change of 6. So then we do 6 divided by, which one? 25, yeah, the original, 25. Okay, so 6 divided by 25, that's 0.24. Change that to a percentage. 24%. Was it increase or decrease? Increase. We went from 25 to 31, so it was an increase. Okay. Again, the main thing to remember on these percentage change problems is that when we divide, we have to divide by the starting number, the original amount. And because if you divide by the new number, you're gonna get the wrong answer. Okay. Got to divide by the original. Okay. Questions on that one? All right, so on this last part, we don't have any calculations we have to do. And all we're doing is we're going to look at some things to avoid when you're working with percentages or when you're seeing percentages given to you. Okay, a lot of information is communicated in percentages, so you want to be aware of these things when you're looking at those numbers. So our textbook calls them percentage faux pas. Okay, stuff you shouldn't do. Okay, so the three big things we need to avoid. Okay. First one, if we've got two groups of really different sizes, so like we have a really big group and a really small group, and we're looking at some percentage about each one of those groups, it's not real meaningful, okay, not very meaningful to make that comparison, and we'll see that in a second. And so we want to try to avoid that. The second one says we don't want to average percentages. So what would that be like? That's if we've got a bunch of different data that's percentages. We don't want to add them together and divide by how many we have, right? We don't want to take the average, and we'll see why that is not a good idea. And then the last one's really tricky. Okay? Something that's hard to catch if you're not looking for it. Something we're going to call shifting reference points. Okay? So we're going to look at an example of when each one of these can be misleading. Okay? So let's do the groups of different sizes first. Okay? So here's some information we're told. And it says 75% of people living in Alaska favor free skis for school children. While only 40% of Californians favor free skis for school children. Okay? So that could be a factual statement, but it can be misleading. Okay? Because if you're not careful, and you're looking at the percentages, it might make you think there are more people in Alaska that support that idea than in California, but that's not true. Even though the percentages are set up like they are, the sheer numbers are different. So let's look at how that works out. Okay. So it says in 2010, Alaska's population was about 710,000. California's population was about 37 million. Okay. So quite a difference in size there. Then let's figure out actually how many people were in favor in each one of these states of these free skis. Okay. So 75% of the people in Alaska would be about 532,000 people. Okay. But 40% of the people in California would be almost 15 million people. Okay. So even though the percentage was higher in Alaska and smaller in California, the actual number of people that were in favor of free skis for whatever reason, okay, was way bigger in California. Okay. So the percentages can be misleading. Okay. Percentages can be misleading. Okay. And then this is kind of a little bit mind-blowing here. Just 2% of California's population would be more people than are in Alaska. Something to think about. So if you have groups of really different sizes, percentages, you have to be careful with them. Okay, they can be misleading. The second thing we're told to avoid is averaging percentages. So let's look at one of those. So maybe we'll go back to our free skis example. We had 75% of people in Alaska favor free skis, 40% in California favor free skis. So what if we just wanted to figure out the average percentage for the two states? And we could do that, add it together and divide by 2. That would say about 57.5%, right, favor free skis. But if we actually look at the numbers of people again, okay, It says 57.5% there. But if we actually take the numbers and add them up, and we figured it out, a little over 500,000 in Alaska, almost 15 million in California. Divide that by how many people are in both states. That's only 41%. Okay? So taking the average of the percentages was way off. Okay? There's a big difference in between, especially when we're talking about millions of people. And there's a big difference between 41% and what do we have, 57.5%? Yeah. That's way off. So averaging percentages, usually not a good idea. And let's look at this last one. Okay. This is this idea of shifting reference points. So let's look at this information. It says campus police reported that car break-ins on campus decreased by 25% this year compared to only a 20% decline the previous year. Okay. So what's that make you think? Maybe they did a better job preventing car break-ins this year? Because it went down 25% this year and it only went down 20% the year before. Okay. That's the idea, hey, we're doing a good job now, doing better than we were doing. Okay, but if we actually look at the numbers, so year over year for that first year, car break-ins went down by 2. And then year over year for the second year, what was our absolute change? 8 to 6, that was just 2 again. Okay. So it decreased by 2 both years, but the percentages were different. Okay. Why? Because here, if we're calculating our percent change, right, from here to here, we divide by 10. And then on the second one, going from 8 to 6, if we are calculating percent change, we divide by 8. Divide by 8. So the problem with this is that we're referencing our change from 10 to 8 and then our change from 8 to 6. Okay, so the place we're referencing is changing. That's the shifting reference point. Okay, so our denominator was 10 and then our denominator is 8, and it makes the percentages misleading. It makes the percentages misleading. So something to watch out for. Watch out for. Questions on those? Might not excite you. That little last part with those 3 things is stuff I like to know about. I like to know some math that keeps me from being deceived. Maybe it's not that interesting to you. No questions? Okay, so Friday is Hawks Day. Okay, come, you want help on Hawks, or you want to work on Hawks together? Okay, come on Friday. If you're caught up on Hawks, do what you want to do. Okay. So I will either see you Friday or Monday. Okay.